In our plus 2 days, we have just seen the notions of limits, where we will leap from algebra to analysis side. So while doing the preliminaries of calculus, the limit concepts are so important. And let us just recap what we have done. Consider a function f of x, which I may write it as x square minus 4 divided by x minus 2. This function is a rational function. It is defined everywhere except at x equals 2. Let us look at the behavior of the function whenever we are nearing 2. At 2, the function is not at all defined. It is not in the vicinity of the definition of the function, the domain of definition. But just look at the form of the f of x, which is x square minus 4 by x minus 2, which I can rewrite it as x plus 2 into x minus 2 divided by x minus 2. Then, since it is, if you are not allowing x equals 2, we can cancel off these x minus 2's because if our x is away from 2, this is well defined. And we are going to get f of x behaves exactly like x plus 2 now. But f of x equals x plus 2. We know that it is y equals x plus 2. This is a well-known function for us. It is just a straight line. But all this behavior of the function is whenever x is away from 2. It is not equal to 2. So remember that. Let us just look at how the behavior whenever you are nearing. Nearing 2 means the domain 2 is there. For this function, we can definitely count, this is y equals x plus 2. But nearing 2 means either there are two approaches towards 2. Either one can come from the right hand side or one can come from the left hand side towards 2. So 2 is avoided. It is not in the domain of definition. One can start with 3, 2.5, 2.99, etc., etc. And through that way it can be, one can nearer and nearer and in such a way that 2 can be approachable. So what happens from the evaluations or the functional evaluation is nothing other than that. If you are looking at the graph, it will just flow from up to down, and we will be coming down and down and down and towards zero, this form. So whenever you are coming nearer and nearer to 2 from the right hand side, the graph will mark towards 4. Remember that the original function x square minus 4 by x minus 2 is not defined at 2. Very similar way, if you are looking from the left hand side movement, somebody is giving 1.99, 1.999, etc. Then this graph will rise up and it's trying to mingle with the evaluation 4. So go nearer and nearer to 2. That will make your functional evaluations nearer and nearer to 4. This is what is happening. So how much nearness you can achieve towards 4? As much as you can, by just making going nearer and nearer to 2 like that. So by making x is nearing to 2, either from left or from right, one can move the functional evaluations as much as near to 4 as we like. This notion is referred as limit of f of x as x is tending to 2 or approaching to 2 is going to be 4. This was the intuitive idea of the limit. So we say that the function is having limit. Limit here means two-sided limits as x is nearing towards 2. It just gives you what happens. X is nearing 2. We can symbolically write like this. As x is approaching 2 from both sides, this will give us our f values, I mean, going nearer and nearer to 4. So this idea from left as well as right, depending on the function, obviously having one-sided. Before giving the one-sided idea, let me just recall the general definition in this situation. Just go nearer to A. I mean, A may not be inside the domain of the function y equals f of x. It is immaterial whether it is defined or not at all. But there should be a way to approach A from left as well as from right. So both ways one can approach towards A. It means that in an open interval containing A, the function should be defined. So you can go nearer and nearer to A as much as you like. A is a very general point for this function. So once it is sure that whenever you are moving towards A from the right, the graph in this situation flows down and mingle with the evaluation L. So it's compressing from coming from up to down like this. Now, very similar way, if you are approaching from left to A, then the graph actually rises and mingles with this L again, which says that go nearer by making nearer and nearer to A, one can go nearer and nearer to the real number L, which is the idea what we have already defined. Limit of f of x as x nearing towards or approaching or tending towards A is L. So this is guaranteed by nearness towards the input A, towards the A, we will get f of x nearing towards the real number L. F may not be defined at A, that is most important. Even if it is defined, that value is not going to give any role in this in the definition of limit. This is the two-sided way of, or we will say that it is exists, the limit exists at A. Now, a situation may arise whenever you are considering a point A, but all the right-hand side values, I mean, for example, our greater values, through the greater values, we can approach A. Such a situation also may come. For example, if I am considering a function y equals f of x like this, the graph is given like this. The input values are from the right only. We can't approach A from left. It is, once again, remember that A may not, at A, the function may not be defined. It doesn't matter. So if you are moving from right and the graph in this situation flows down to L, so we will say that limit f of x as x is approaching from right to A is L. This is how the right hand side limit is defined. So limit f of x as x tend to A plus, we will write, is going to be L. A is nearing towards A. From the right, it implies f of x nearing towards L. As much as close to L you can move by just moving x from right to A. Only greater values of A are considered. Analogously, one can define the left-hand side limit too. Suppose my function is like this, y equals f of x is defined like this. So A is somewhere here. That at A, function may not be defined, we don't consider, but you have a way to approach A from the left. Then from the graph it is clear that it is coming down and down and down, and obviously it takes x nearing towards L. So we will say that limit of f of x as x tends to A minus is L in this situation. So x you allow to move nearer and nearer to A, you will get f of x is going nearer and nearer to L. As much as you like. This is the situation. So whenever we say that a limit exists, generally speaking, in an open interval containing A, you have two ways of approaching from either from left or from right. So two-sided limit in that case exists. We say that particular value L is the limit. Also, it may come from the right-hand side limit only, left-hand side limit only. So this what we have done in our +2 days, but obviously These notions will help us, at least graphically, the intuitive idea like this will help you a lot, and we will discuss it. We have already introduced the concept of limits. So the function is defined in an open interval containing a. So it is defined everywhere in the neighborhood. I mean, open interval containing a, except possibly at a itself. Then we say that a f of x is having the limit L as x is nearing towards a or extends to a. If and only if the f values can be made as close to L as much as near to L by making x sufficiently close to a. But whenever you are making the input x sufficiently close to a, you have to remember that either from left or from right you can make it. So two-sided way you can approach it, and the function is approaching this real number L. In that case, we used to say that it is having the limit L. The f of x is having the limit L. It's a two-sided limit concept. If it is working only on the one side, we can analogously we have defined limits from the right as well as limits from the left. So limit of f of x as x is nearing towards a from the right, it is denoted in these notations. Whenever you are approaching a only from the right, input values are just greater than a, but you have a freedom to reach towards a. So it should be the domain also should be defined in such a way. The right side of a, it is defined, not possibly at a. So you can just come very near to a as much as you wish. And if you are sure that f of x is nearing towards L, then you say that it is the function is having the right hand limit as L whenever s extends to a, plus we used to say right. Very similarly, if your function is defined very near values left to a, that is possibly a open interval left to a, not it is except possibly at a always. You are not worrying about what happens at a, but nearing to a from the left. That is what is denoted by extending to a minus. So f of x is said to have the left hand side limit as capital L. You approach your a from left in the domain, then in the range or the codomain, what happens is your f of x values can be made as close as L as you wish. That is what is the whole meaning of left hand side limit in this case. So both right hand side limit as well as left hand side limits we can define, and two-sided limits also we have seen how both approaches agrees and coincident with the same value. That is what is going to happen. So that is a fact, in fact. So that is as a theorem we can write it and prove it if you like. Yeah. So let f be a function which is defined in an open interval containing a. So whenever your function is looked at, again not possibly defined at a. So either you can have from you're approaching to a from right or left. So right limit as well as left limit exist. They are coincident to a value L, and that value is going to be the two-sided limit. So this is altogether you can make it into a framework of a theorem. Suppose f is a function which is defined on an open interval containing a but not possibly defined at a. Then f of x, then limit of f of x, you mean two-sided limits in that case, equal to L if and only if both the right hand limit as well as the left hand limit as x is nearing towards a exist and it should be the same L. So we can try some examples. See, one easy example is Heaviside function. The function is defined throughout the real numbers. It is defined for all negative real numbers, just 0. and all non-negative real numbers simply 1. So on the graph will look like this. All the left hand side you have to make it 0 up to 0. Then 0 onwards you have to make 1. This is how the graph look like for h of x. Now if you are looking at what you can say about the limit of the function at 2, for example, you can approach 2 from left as well as right, but always it will be stable with the evaluation 1. So left hand limit as well as right hand limit for h of x exists for when we are nearing towards 2, that is going to be coincident with the evaluation 1. So limit exists and 1 is the evaluation. Any non-negative real number, this same will happen. Very similar things will happen negative real numbers. Also, they will have the limits. Either you approach from left or right and you will be getting the same evaluation of the limit as 0. But on the other hand, look at the input 0. By definition, evaluation of h, that is h at 0, is defined to be 1. But that is far away from the limit, you can see, because see, suppose you are approaching 0 from left. All evaluations of h of x are taken to be 0 here, and what it says is the limit of our h of x as x is nearing to 0, that now from left side, so I will write like this, 0 minus, that is going to be 0. On the other hand, if you are looking at h of x as x is nearing towards 0, but now from the right, always the evaluations are 1, we know. So as much as close you are coming to 0, it will be always 1 only. So this gives you 1. So left hand limit of h of x is 0, right hand limit of h of x is 1 as x is nearing to 0. They are differing, which means two-sided limit or limit does not exist in this case. They are not coincident. These two-sided limits are not going to be coincident. So various examples one can look at, but we can try at a rough figure which I have plotted here for f of x. So from the figure or the graph, it is defined from minus 7 to 7. Minus 7 excluded and 7 is minus 7 is excluded and 7 is included. So just we can have some particular points and see what happens for the limits notion and all. See, for example, at 1 we will try to discuss first. At 1, functional value is defined to be 1.5. One can look at limit of f of x as x is nearing towards 1. So for that, you have to consider from left as well as from right, and we have to look at the evaluations coincides, that value is going to be the limit, and we say that the function has the limit or the two-sided limits. Obviously from the graph what happens is if you are coming from the left and nearing values of 1 and nearing towards 1, then the graph will come nearer and nearer to 1.5. So this evaluation is going to be 1.5. Very similar thing will happen from the right also. If you are approaching to 1 from the right side, the domain side, then our graph on the function will approach towards 1.5 again. So this also will give you 1.5. So left hand limit as well as right hand limit exist and they are going to be the same. So we say that limit f as x tending to 1 exists and the limit is going to be 1.5. Just we can look at some other points also, some typical points also. Now if I am looking at for example at minus 4. Minus 4 is also in the domain. So here let me check what happens for the limit. So at minus 4 f of x value is given to be minus 1. Let it be there. That is not going to give anything here for the discussion of limit. Now limit of f of x as x is nearing towards minus 4, but from the left side if you are looking at, look at the graph and the flow is like this, and you will be reaching at minus 1 you are approaching to minus 1 very closely. So which says the limit of f of x as extending to minus 4 from the left, the limit is minus 1. Look at from the right side, suppose you are approaching minus 4, that is x tending towards minus 4, but now from right. Then the graph of f will say that you are approaching towards 0. It is merging like this, which says left hand limit is different from the right hand limit. That is one-sided limit. If you are looking at that, f of x on the left hand side is also coinciding with the functional value, but this is not at all important in defining the limit. But these two fellows are different, so limit does not exist at x equals minus 4. Very similarly, you can think about even at minus 7 is not in the domain, but one can approach minus 7 from the right. So what happens is, if you are approaching minus 7, you will be nearing towards minus 3. So right hand side limit exists in that case. So limit of f of x as x tending to minus 7 from right side, that is right hand side limit exists, and that evaluation is going to be minus 3. But you can't talk about left hand limit in this case. It is, you can't approach minus 7 from here. Very similar way, one can think about various other points. For example, at 3 also we will just discuss it. So at 3 what happens? At 3, if you are approaching the function from left, that is limit of f of x as x going to 3, but now from left, the graph will be flowing like this and it will end up here, which means you will get the value 1. One can come from the right hand side also, that is from this side. For that, this is the part of the graph. So limit of f of x as x going towards 3, but now from the right side, then it is approaching towards 5. So this evaluation is going to be 5. So limit of f of x as x going to 3 from right side is 5. But if you are approaching from left side of 3, you will be getting 1. So this one-sided limit exists. This is 1, this value is 5. But they are not equal. So limit does not exist at x equals 3. Also look at the evaluation in the graph is defined as 4. That is f of x value at 3. That is f of at 3 is actually going to be 4. But that is not at all important in this situation. For considering the limits, we just have to look at left hand side exists or right hand side exists, whether they are coincident with a real number. Yeah. So all other points, whatever be the points you are interested, you can look at, and various graphs also you can look at.